line, they're called Anderson connectors, that I can connect different things to that charge directly off of 12 volts. Some handheld radios are one of them, and some other devices which I have. I connect directly to 12 volts, so I don't have to use an inverter or a different type of charger. I connect right to here. Okay, so this is something that I use to charge up some of my devices. You don't have to do that. This is a personal thing for me. But you do need a charge controller. Now, from the battery, right, it's now nighttime, and I want to operate something. And I want to operate something that is, either 12 volts, fine, I plug in directly, right? I can plug in right to here, and I have a full 20 amp hours worth of 20 amps at 1 hour, or all 20 amps for 1 hour, right? I can do it all at one time right here. Okay? Or I can go through and use an appliance. An appliance is what some of us like to use. I'm asked consistently, what about my bread mixer? How about a wheat grinder? Right? And so, how do we do that? We have a fully charged battery. We go through an inverter. An inverter does one thing. It takes a DC voltage out and creates AC, just like we have on the wall. Now, there's two types of inverters you need to be aware of. One produces a pure sine wave. A sine wave is how the alternating current, 120 volts AC, which is in our wall, it's nice, beautiful, wavy sine wave current. Sine wave voltage, excuse me, it goes up to a peak, crosses zero, it goes negative. Positive to negative, that's what it does all the time. 60 cycles per second, or 60 hertz. 120 volts, 60 hertz. A good inverter will produce something close to that. It'll be off a little bit, it'll be a little bit choppy, but it'll be good for a computer who likes clean power, right? Clean power. There are some inverters that don't produce a nice clean sine wave, they'll produce a sawtooth wave. So here's what I mean. In our wall, if we look at an axis, a sine wave, I'm saying, goes like this. And it's 120 volts at the peaks. Excuse me, 60 volts at the peaks. For 120 volts difference. Note at 120 volts. Okay, a good sine wave out of an inverter will look something like this. As close as it can, but it's probably something like that. Okay, because it has to rebuild this sine wave from something that's a direct current, like a battery. Like a battery. A bad inverter, but can still be used to charge many devices. Okay, I would recommend a computer would be something, a better one, but a not quite as good or not quite as expensive one will produce a sine wave kind of more like this. Okay, where it kind of rounds off or points off the tops. So I'm not saying this is bad. I would use this for charging most of my electronic devices, and I'd be just fine with that. But when I want to have something that's a piece of technology, like a camcorder, like a computer, I'd probably buy a little bit better one and produce a sine wave like this. Okay?
You know what kind of sine wave it produces before you buy it?
It will say on the box like a true sine wave or true 120 volts output. Some indication that it says it's producing a better sine wave than another one. Does that make sense? They're all different. They rate them all differently. You just have to look at the verbiage. I would definitely go online and find out some information about their inverter before you purchase. Okay? All right. Thoroughly confused yet? We haven't even talked about the fun things yet. We're just getting there. It's all math so far. But this is so important. We're giving you a base so that you can decide for yourself which would be best, what kind of technology would be best for your personal needs. So, going on, so from the inverter, Okay? The inverter can now power electronic devices, appliances. And of course we get asked all the time, what about a bread mixer or a wheat grinder? Any questions so far as we talk? Yes.
So that inverter
Yes.
is how many volts, or what would you recommend
Okay.
getting as far as the
All right.
wattage volts?
Yeah, that's a great question. That's a great question. So the inverters, this is a 1,000, which means it can do 1,000 watts. Okay, 1,000 watts. 1,000 watts, what does that equate to? I did the example in our handout of a 600 watt blender, which probably isn't too far off, but it was a guess. I wanted the math to come out to be even numbers, to make it simple. So I padded the answer to make it look good. The inverters, I would pick some for your needs. For example, I picked a big one for this example because I wanted to grind some wheat, or at least show that the wheat grinder could operate under this condition. But if I'm charging my cell phone, I don't need 1,000 watts, right? A smaller device will work just fine. And so maybe a 250 watt device, or even something 250 or 500 watt device is plenty for that. It's plenty. Yes, Richard?
Sometimes if you're looking for an inverter, you need to look for something that will be a little bit more than you need, because of the fact that when you go to start up these motors, they have
Yeah.
a startup that is much more than what they're rated for.
Okay, I'm getting to that.
Okay.
Okay, so yes.
Or will it hurt something that's less than it? If you're doing it, if you're charging a phone with that 1,000, is that harmful? I mean, do we
Yeah.
need-
No, you just pay a penalty in battery life for the electronics in the inverter that running but you're not using.
So what he just said is, I'm gonna address yours in a second when I turn this thing on. What was just stated was, is there a problem by charging a cell phone which takes 5 watts by an inverter that has 1,000 watts available to it? No, not at all. The electronic device will consume what it needs to accomplish its task. If it's 5 watts, even though 1,000 watts are available, it'll consume just 5 watts. That's just the laws of nature. Okay? Yes, another
Okay.
question.
When you're doing this, is it roughly about a 20% drop that you'll lose as far as power-wise, running from your DC to your inverter here? So if you can all get products that are 12 volt, you'll be much better off. You won't have a voltage drop or a power loss just from converting it from DC to AC.
Okay. So, all this,
I know you're getting to it,
it's
sorry.
on the list, right? Okay, so what we now are thinking of doing is, can a 1,000 watt inverter run one of these? It can, underneath 2 circumstances. One, it's large enough to do it. I mean, this takes 800 watts, that's 1,000 watts. Under load. Okay, this is not under load, this is just free spin motor. There's no wheat in here. So we think of what's the best opportunity for success, and this is it. 1,000 watts, takes 800 watts. I've got some room on this, I got 200 watts left over, plenty, right? What's the efficiency of an inverter? Is it 100% efficient? No. 90-ish, okay, maybe 90-ish% efficient. And is it indeed a grinder any good if there's no load on it? I mean, it's okay if I free spin the motor, but what if I put wheat in it? Will it be harder for it to spin? If it's harder for it to spin, it takes more work, which means more what? Watts. You guys are good. See? The math